So here there is a pulley system. Okay, there is a mass of 2m over here and there is a mass of m over here. Both the masses are connected to these pulleys B and A. Okay, there are two pulleys B and A, and there is a string which is going over these two pulleys B and A. Okay, and this end of the string is attached to the mass m, and there is this 2 times mass m which is attached through a string to this pulley B. Okay, now this pulley B is a movable pulley. Okay, it can move. Okay, in such cases what we have to do is we have to see how the motion of this particular block of mass m will affect the motion of the pulley B. Okay, so let's do that. Okay, so what I will do here, I will take this particular system of coordinates, for example, so system of reference. It will be, suppose here, let's say I take the origin. Okay, then there is this length x. Okay, and the coordinate of this pulley is x, the pulley B. Okay, so this particular point is my origin, and with respect to origin, the coordinates of the pulley B is x, and the coordinate of the coordinate of the mass m, let it be y. Now what you can see from here, the length of this particular string, the blue color string over here, is 2x plus y is the length. Now if I differentiate with time, what I will get? So 2 times dx by dt plus dy by dt is equal to 0. So I will get 2 times Vx plus Vy is 0, or I can say 2 times Ax plus Ay is equal to 0. I differentiated again. So as a result, what I will get? Final result, Ay is equal to minus 2 times Ax. Okay, now what does it mean actually over here? Here what does it mean? From this expression, what I can say is that the rate at which this particular coordinate y is changing, that is dy by dt, the coordinate of this mass m, is double the rate at which this pulley's coordinate, that is the pulley B coordinate, is changing. Okay, so it is double the rate. Now the minus sign is because since y is increasing and x is decreasing, that's why. So we don't have to consider minus sign when we are applying the free body diagram. Okay, so remember that this mass acceleration, if you take as a, then you have to take this 2m acceleration to be a by 2. So we will do that. Let's go to the next. Okay, so here the acceleration of this particular block is a by 2, and for this it is a. Now let's apply the free body diagram. Okay, so here on this 2 mass 2m, there are two forces. Okay, there is only one force. Okay, which is the tension, this tension T dash. Now if you look this tension T dash, here there will be two tensions like T and T. Why both are same? Because they are part of the same string, right? The same string is going like this over the pulley and attached to the mass m. So this 2 T will be equal to T dash. So here T dash, instead of T dash, I will directly write 2T. So now this 2T is equal to 2m into acceleration. What is acceleration? A by 2. This is the first equation. Now the second equation will be for mass m. For mass m, what is the scenario? The downward force is mg and upward force is t. So that will be mg minus t. Mg minus t is equal to ma, because we assume that the acceleration of mass m is a. So then we have to solve these both equations 1 and 2. So what we will get by solving? So I can cancel this 2 and 2. So T is ma by 2. So we have mg minus ma by 2 is equal to ma. So this gives us that mg is equal to 3 by 2 ma. So m and m gets cancelled. So g is equal to 3 by 2a. So a is equal to 2g by 3. Now the question is that we have to find out the acceleration of the masses. So we have found out the acceleration of the mass m, capital mass m, and then for mass of for the block of mass 2m, it will be a by 2, that means g by 3. Now tension also you can find out easily. Tension will be, just by substituting you can find out tension. So tension here will be, since T is equal to ma by 2, okay, T is equal to ma by 2, the tension will be mg by 3. Okay, just I am multiplying m by 2g by 3 and dividing by 2. So this will be the tension. Now the next is a crucial part. This question contains another part, that they are asking what is the force exerted by the clamp on the pulley. Okay, what is the force exerted by this clamp? Okay, there is this clamp like this. Okay, I will show it over here. This is the clamp. What is this force which is exerted by the clamp on this particular pulley, the yellow color circle? Okay, what is it? So we will analyze what are the forces acting on this particular pulley. Okay, so here because of tension, okay, the force will be on the pulley due to this particular tension in the string will be like this. So let me go to the next page. So here we will show like this. So this particular area I am drawing again. Okay, so here the two tensions are like this. So here the tension T is like this, here tension T is like this. Okay, now if I join them, then they will be perpendicular to each other. Now perpendicular to each other, and there is a clamp like this. Okay, there is a clamp. They are asking what is the force by the clamp on the pulley. Okay, now there will be on the pulley, there will be a force by clamp. Okay, force by clamp. Okay, and the force by this string. Okay, force by this string. But now addition of these two forces will be 0 because the pulley is not moving. Okay, there is a rotational motion of course, but there is no translation motion, so it is not moving. So what will be this case? T and T both are at a 90 degree, and we know that if two vectors are 90 degree, at 90 degree, it is resultant is root 2 T. So root 2 times T, which is root 2 times, what is the T that we found out? Mg by 3, root 2 mg by 3. So this is the force exerted by clamp. Okay, exerted by clamp on the pulley. Okay, this is the force, because F clamp plus F string is 0. Okay,